Hey, let's take a look at this Bellringer here. It says if cotangent, and I know it's an alpha, I'm gonna say A. If cotangent A is -7/24 and located in quadrant 2, and secant, again, I know it's beta, but I'm gonna say B, is 5/3 and located in quadrant 4, find sine alpha plus beta, sine A plus B. Okay, let's start with this. Let's just give a quick drawing. Quadrant 2. If I were to draw quadrant 2, is that top right, bottom left, top right, top left, bottom right, bottom left? Where's quadrant 2? Top left. Okay, so my drawing, I want to draw it kind of like this to make it easier. And I'm going to put a triangle. Anytime you draw a triangle, I recommend always doing it standard position. You'll learn in chapter 8, 9, because it has huge shortcuts. So standard position is when it connects to which axis? X-axis. So let's connect our triangles to the x-axis. Like so. Now they gave us two sides of this triangle. And they did so by telling us cotangent's value. Sine is y, cosine is x, tangent is y over x. Once you think about cotangent, if you don't know, it's there on your cheat sheet, you can look at it. Cotangent is 5, 4, 3, 2, and 1. X over y. The purpose for the drawing is to indicate which value is negative. With our drawing, is the x value the negative or is the y value the negative? X. Y is going to be a positive 24. X is -7. We're missing h. How can we find h? Pythagorean theorem. So x squared plus y squared equals h squared. We plug in our numbers. The -7, I want to put parentheses just in case you're a calculator user. If you don't put that in parentheses, calculator follows PEMDAS and will square the 7, then do the negative. That's not right. You want it to be -7 times a -7. If you think about mental math, what that is, or calculator, be typing that in, and that will equal 24. Oh, I messed up. Someone correct me. How did I mess up? I put 24 in place of the hypotenuse. That's not where that goes. 24 is the y. Okay, so I corrected it. So -7 times -7 is not -49. You've got parentheses. Positive 49. There you go. Positive 49. 24 times 24. 576. Good. And so we need to add those together to get our hypotenuse square. Oh, you already did. 625. 625 is our h squared. So now the last step. What is the opposite of a square? Square root. Typically, I'd say it comes with a positive or negative. This time we don't have to because we know, based off of what quadrant and what variable, that this has to be. H is always positive. H is going to be the positive of that square root. What is the positive? What is the square root of 625? 25. Now I'm going to pause that triangle. We'll come back to it. I'm going to call this triangle A. Put the A there. And now we're going to take a look at triangle B. So triangle B, they tell me that's in quadrant 4. What quadrant? Top right, top left, bottom right, bottom left. Where's quadrant 4? Bottom right. Bottom right. So I'm going to draw it this way this time. And again, whenever you draw a triangle in standard position, which axis should it always connect to? X-axis. They describe to us side lengths for this triangle, saying secant is 5/3. Sine is y, cosine is x, tangent is y over x. Secant would then be 5, 4, 3, 2, 1. H divided by x. Good. This is triangle B. Do not forget that B there. So it would be h is 5 and x is 3. We could do Pythagorean. My guess is some of you know, whenever you have a triangle that's right, and it's a 3 blank 5 triangle, 3 blank 5, what's the blank number? 3, 4, 5. This one's going down though, so we actually going to list it as Y equals 4? -4. Now, if you don't know a 3, 4, 5 triangle, how could you get that leg length again? We could do Pythagorean theorem again, but we'll just say that's a Pythagorean triple, a 3, 4, 5 that we've seen so many times. Okay, so what can we do with all that? Now that we have these two triangles solved, we can actually solve the problem. If you were not here last class, we talked about, well, you can find the sines, cosines, and tangents of angles either being added or subtracted from one another using a formula in the formula chart. They asked us to find sine A plus B. So what we're going to do is go to our formula chart, and I'm going to pull the formula for sine A plus B. So look for sine A plus B. Where is it? Oh, it's down towards the bottom of my screen. Right here, sine A plus B. That's the formula we're going to pull right here. Just copy and paste this here. That's my formula I'm using. And now this is way too large. So it says sine A plus B would equal all these values. Sorry, it got so stretched, but we'll figure it out. So if sine A plus B equals all that, then we can say sine A plus B will be, well, you take the sine of A. So you look at triangle A and sine, let's think of our ratio. Sine's Y, cosine's X, tangent is Y over X. What is sine's ratio? 3, 2, 1. Y divided by H. So in this case, it'll be 24 divided by 25. Now this needs to multiply times the cosine of triangle B. So now we look at this triangle. Now what is cosine's ratio? 5, 4, 3, 2, 1. X over H, which would become 3/5. Plus cosine triangle A. Let me extend this a little bit, make it easier for you to see this. Cosine of triangle A, 5, 4, 3, 2, 1. It's X over H, so -7 over 25. And this would multiply with sine of B. This form, sine of this triangle right here. Sine is Y over H, so 5, 4, 3, 2, 1. There we go. As you go to simplify this, you might notice something about the two denominators. What do you notice about these two denominators? They're the same. So we can combine it into one fraction. Mental math here. Do y'all know what 25 times 5 is? 125. That's going to be our denominator. I have 24 times 3. 24 times 3 would be 72. Good. Plus, this will be a negative times a negative. What happens with a negative times a negative? They will go positive. So it still will stay a plus. 7 times 4 is 28. So 72 plus 28 is 100. So we have 100 divided by 125, and that can simplify. 25 goes into both those numbers. 25 goes into 100 4 times, and 25 goes into 125 5 times. And so that would be our answer there. So that right there was a review of these two triangles. Would be like lessons 4-1. When we first came back from Christmas break, I taught you a few things specifically. That one, when you solve with a triangle, we're always going to connect it to which axis and freak out? X-axis. That's called standard position. I taught you that. Number 2, I reminded you of geometry. That Pythagorean theorem, if it's a right triangle, x squared plus y squared will equal h squared. And third, I taught you that first day that h is always positive. Those were some of the rules I gave you. So the top part of my screen here would be lesson 4-1. At the bottom was what we did last class. Is you can take sine or cosine of multiple angles added together. And what I did is I just kind of made it tricky. And that the two angles you're adding up were not like a 30 degrees and 45 degrees, which was what we spent most of the time last class doing. What I did that was different is instead of the angle, I showed you the triangle. If I wanted to draw this perfectly correct, here's one thing I would need to change. Now that I've done the problem, I'll show you. I would actually not put the theta there. I would have put the A there. So it's saying sine of this triangle, and I wouldn't have put the theta there. I would have put the B right there. Now it's even a better drawing. That's technically how I should have drawn it to make all the math work perfectly. Okay? Questions?